Morning anatomy classes. This is the second part of lectures for the digestive system. Asked a couple questions. Those are due tonight. Make sure you look at those. Those are on Google Classroom, and the answers should be pretty easy to find. Today we're going to start talking about what I would have done in lecture with you guys. It's called a food trace. So imagine, say you go out and have a cheeseburger for dinner, or if you don't like cheeseburger, a bowl of pasta, whatever. What does your body do to that from the time that you start chewing it up, from the time you put it in your mouth, until it's processed, until it's absorbed, until whatever you can't digest is removed from your body? So over the next lecture or two, and the notes that I'm going to give you on Google Classroom, we're going to discuss just exactly what happens to that food as it passes through your digestive system, also known as the alimentary canal or the digestive tract. So let's start with the mouth. It's a logical place to start. You want to go in order when you do these things. When we look at digestion, it can be broken into two forms, physical or chemical. Physical digestion involves just changing the food's appearance, smashing it with your teeth, tearing it into pieces with your teeth, adding saliva to it to moisten it and soften it, mixing it. Those are all physical aspects of digestion, very important. Chemical aspects of digestion, just like we talked about chemical and physical properties earlier in the year, chemical aspects of digestion involve changing the actual chemical makeup of the item that you've eaten. So say, for instance, if you take a cracker or a piece of bread, which is starch, and you put that in your mouth, you start chewing it, you're breaking it down physically, but at the same time you're adding an enzyme to it from your saliva called amylase. What amylase does is it literally breaks the bonds between the starch molecules and turns them into smaller molecules called dextrose. Dextrose is a sugar, and you can actually taste that change in your mouth. Not advising you to do this at home, but if you're bored and you want to try it, take a cracker, a saltine cracker, or a piece of bread, keep it in your mouth, chew it up for a minute or two, and keep it in the corner of your mouth, and then move it back over into your tongue, and you'll notice that it now tastes sweet. It doesn't have the same taste as it did, the kind of the bland taste of the cracker, because what your body has done, what the amylase has done, is chemically change those molecules, and now obviously they have different properties. So to start out in the mouth, I already mentioned some things that happen there. In the mouth, you're going to chew the food, you're going to use your teeth to tear the food, to grind the food. You're going to use your tongue to manipulate the food around your mouth, and then the saliva softens it, moistens it, makes it easier to swallow. In addition, the saliva, as I mentioned, adds amylase to the food, which is going to start breaking down the carbohydrates. Remember, there are 4 macromolecules that we're going to be interested in breaking down into smaller pieces. Those would be carbohydrates, lipids, proteins, and nucleic acids. The only one that has any type of real chemical digestion occurring in the mouth is going to be the carbohydrate aspect. So once you're done chewing, you're going to have to move the food to the back of your mouth using your tongue. Then you're going to swallow the food. Swallowing is an involuntary reflex. I know that doesn't sound like it's probably counterintuitive, but at the same time, you can initiate the swallowing reflex by pushing the food to the back of your mouth. But once you do it, it's kind of like sitting at the top of the hill on a roller coaster. Once you push it off, you're no longer in control anymore. It's going. And that's going to be initiated by smooth muscle contractions of the digestive tract. And how does that happen? Or what's that called? It's called peristalsis. It was one of the questions that I asked you. Peristalsis is the involuntary, rhythmic, directed contractions of the digestive tract, the smooth muscle in the digestive tract, starting in the esophagus. So once you swallow your food, it's going to pass through that common area in the rear of the mouth called the pharynx. The pharynx, we obviously talked about that with the respiratory system. A lot of things pass through there. Food, water, air. We have to separate those things. So when you are breathing, what will happen, or rather, let's look at it this way. When you're swallowing food or water, there's a flap of cartilage at the base of the trachea, and the esophagus and the trachea are right next to each other in the back of the pharynx. So when you swallow food, there's a flap of cartilage that will click shut over the trachea, and that's going to keep food and water from obviously entering your lungs. You don't want that. That's for respiration. Food and water in your lungs is the definition of what we would call choking. So once that happens, when you do swallow the food, that epiglottis will cover the trachea opening, keep that out of the lungs, and then allow the food to pass in the esophagus, which is a tube. Tube goes from about right here to about right here. Literally a foot and a half depending on the size of the person. It's going to pass through your thoracic cavity, through your diaphragm, and then obviously connect to the stomach. It is a food tube. Its job is to carry food from your mouth to your stomach. Limited digestion is going to occur there, and nothing really intentional. Obviously, you're going to swallow some of the saliva that has the amylase in it. There's no intentional digestion that occurs. Your body wants to get the food from point A to point B as quickly as possible. So if you actually watch when you swallow food, and maybe I'll try to find a video later to show what the esophagus looks like, it kind of looks like somebody has a tube and they're squeezing it in sections as it goes down. It doesn't just drop into your stomach. So there's actually rhythmic contractions. Obviously gravity helps, but you could swallow food sitting on your side. Again, don't try that. It's not a healthy thing to do, but your esophagus is perfectly capable of pushing food to your stomach, whether you're sitting upright or not. So once it gets to the stomach is an organ that just about everybody knows, is familiar with. You don't have a stomach ache, even if you might not have a stomach ache. The stomach is about the size of a boxing glove. It's about 10 inches long. It's capable of holding up to close to probably a gallon's worth of food or liquid or whatever you would put into it. Very adept at doing that. It stretches. It's elastic. It'll shrink if it's not full. Save space, but it's basically a storage and digestive organ. So you can eat a meal and it kind of stays in there for a while. Now, what happens in the stomach? A lot of digestion occurs in the stomach. So again, we talked about the 4 things that happen in the digestive system: ingestion, digestion, absorption, and then processing. The stomach is a digestive organ. It doesn't do much absorption at all. So what's going to happen in the stomach is we're going to start breaking down chemically and physically some of the larger things that you've swallowed. So if you've had a lot of protein in your meal, so you had a steak, you're going to use the enzymes pepsin and renin to break down the protein. If you've had a lot of connective tissue, and that sounds kind of gross, but when you eat a ground up hamburger or even a piece of chicken, there's a lot of connective tissue, and there's pieces of tendon, there's connective tissue between the muscles. Hydrochloric acid, HCl, is going to break those down, which has a very low pH, so low that your stomach has to have protective measures to keep itself from being damaged, which is usually a lot of mucus and some other chemicals that get released as well. Also released in the stomach is an enzyme called gastric lipase, Lipase. Gastric lipase's job is to break down fats, LIP being lipids. ASE tells you an enzyme, so it's an enzyme that breaks down lipids in the stomach. That's what gastric means. Gastric refers to stomach. So this is what's going to happen. All along, while this is occurring, all these enzymes and digestive juices being released, the stomach is going to be churning, almost like a butter churn, so it's going to mix up the foods. It's no different than you putting a straw or a stir in a drink. When there's some sugar in there and you're trying to mix it up and get it to dissolve, your stomach is going to constantly mix its contents with the digestive enzymes and acids that are being added so the food digests more quickly. Now, one last thing before we conclude for the day. When we eat certain types of foods, it takes longer for some of them to digest than others. Carbohydrates can digest pretty quickly, sometimes within an hour. They're easy to break down. Proteins, sometimes 2, 3, 4 hours are a little more difficult. And fats, even though they're loaded with energy, they're full of energy, take a tremendous amount of time and energy to break down, which is why they are not our preferred source for energy, even though they have a lot of energy per gram, because it takes a lot of energy to break them down too. So they can take 6, 7, 8, 9 hours sometimes, depending on the meal that you've eaten. So think about some of the meals that you've had in the past. You have just a bowl of pasta, you're kind of good to go within an hour or so. Your body's okay, it's not bogged down, because it does take a lot of blood and a lot of energy to a lot of resources to break down this food. So it kind of makes you feel tired after you eat. That's why you get that sluggish feeling. The more heavily laden calorie-laden food that you eat, it's going to take longer to break it down, and you're going to feel even more tired afterwards. So a big greasy meal, you go out and have a thing of French fries, a greasy cheeseburger, and some other fatty foods, maybe a big milkshake. It's going to take your stomach a long time to process all that, and it's going to make you feel tired as a consequence as well. Those are just some other topics that we would probably discuss in class about proper eating habits. So anyways, that's where we're going to go with the food trace today. We're going to do it with the mouth, esophagus, into the stomach, and we'll pick up with the small intestine next time. Have a good day.